A patient weighing 64 kilograms needs to be put onto digoxin. What should their loading dose be to the nearest 10 micrograms? You are also given the following information. The volume of distribution for digoxin is 7.3 litres per kilogram. The bioavailability of digoxin is 0.7. The target concentration is 1.5 micrograms per mil, and the salt fraction is 1. Well, the reason we need these pieces of information is because we're using the following equation. The loading dose, my pen has stopped, it's back. Loading dose is equal to the target concentration times the volume of distribution divided by the bioavailability times the salt fraction. So that's our equation. First thing we need to do is to calculate the volume of distribution. So we know it's 7.3 litres per kilogram and the patient weighs 64 kilograms. So we multiply those two together and that gives us a volume of distribution of 467.2. So if we now put our figures into the equation, the loading dose needed is equal to the target concentration, 1.5, multiplied by the volume of distribution, which we've just calculated. Divide that by the bioavailability, 0.7, multiplied by the salt fraction of 1, gives us 700.8 divided by 0.7 equals 1001.14 micrograms. Another important lesson here, read what the question, how it wants you to express the answer. It wants it to the nearest 10 micrograms. So to the nearest 10 micrograms, that gives us an answer of 1000 micrograms. I think that's important to, as important a lesson as the actual calculation is to read the question in terms of how to express the answer, because if you wrote the top answer, you'd be marked wrong. You need to do it to the nearest 10 micrograms in this case.